Thank you all for coming. How is it going? Is it good? Great. So welcome to this presentation entitled Testing Your Message-Driven Application with Spring. I really appreciate you are here, I must say that, at this time. I know that I'm the only obstacle between you and Friday evening in Barcelona. And boy, I know what those Friday evenings in Barcelona mean, because I used to study in here. So I know things. Anyways, I would like to thank you. Small disclaimer, it's the first time I'm doing this talk in this form, at least, which means one of two things will happen. So either the live coding demo gods will be with me today, or you will be throwing tomatoes at me, in which case I'm happy to report that all of the code is up and running at my GitHub account. Well, not at my GitHub account, but at Spring Code Samples GitHub account. It's up and running. You can check it out and play with it. As some of you have probably no idea of who I am, I have recently joined Pivotal's advocacy team focusing on Spring, which means that I'm apparently Spring developer advocate at Pivotal. I'm a weird kind of developer because I prefer to understand the main problem and talk with the business experts, and I love it more than frameworks. That's why I love domain-driven design, and yet I became Spring developer advocate. Don't tell it to my boss. Is it recording, by the way? I guess. So Spring is also awesome. I love Spring. I also love test-driven development. I practice test-driven development, at least I try to do so. I have a great interest in various architectural designs. Nowadays, mainly microservices. And I tweet under Jakub Pilimon. Here's my blog. Please drop me a line if you want. And about the last one, I'm very excited because I'm a co-founder of an initiative called DDD by Examples, which is basically a bridge between Spring users and DDD enthusiasts. It's a set of projects, currently 2 of them. We welcome you to collaborate if you want. You can find us at GitHub, so please free to reach out and talk with us. Okay, who is here using messaging? Almost always. So I want, almost everyone. So I want you to meet some guy. His name is Stanley the developer. He also is like you, he uses messaging. He is a great developer, maybe not top-notch expert, but he reads a lot, goes here and there, attends conferences, his meetups. He's a constant learner, deep thinker, and so on and so forth. And he's currently responsible for maintaining one big enterprise financial project, which basically issues credit cards. And they issue credit cards under one simple condition: potential client's age. Maybe it's not good when it comes to some kind of conduct, but they just don't give cards to people which are old enough or young enough. But it's private business, so they can do whatever they want. And he was responsible for maintaining this project. And we'll see in a while the new business requirement that comes in that they will develop, and they will use messaging, and we'll see in a while why they chose messaging to implement that feature, okay? So I believe that the code is worth more than 1,000 words of requirements, and the test code is worth more than 1,000 lines of production code. So let's take a look at the test code for this enterprise. So basically 2 end-to-end simple tests. By the way, Stanley loves Spock framework. Is there anyone like Stanley in here who loves Spock? Cool. It's basically equivalent of JUnit. He prefers Spock. He likes mixing testing framework. He will do something in JUnit as well, don't be worried. So happy path, not so happy path. We try to apply for a card, we get the response 200. When the application is rejected, the card application is rejected, we get 403, which is okay. Basically, I guess there is some HTTP post in here, yes. It delegates to some sort of apply for card service, which is application service. And yeah, here we check the behavior, the condition, whether a client was born in 70s or not. If after 70s, then it's okay. If before, then not. I'm sorry. By the way, he applies with client ID, and to 2 first digits from the client ID indicates the year of the birth, which is true in several countries, by the way. Is the font big enough for the guys in the back seats? Good? Great. So, simple scenario, right? And the new feature is like this. So the system must react to 2 kinds of situations. The first one is the card was granted. The second one, the card application was rejected. The system must react in a certain manner. let's say it has to do some update in some reporting tool or send an email to the client or to the potential client. What it is, it doesn't really matter from Stanley's perspective. For his perspective, it matters that this reaction will take place in a different application in his microservice world, because, as I said, he reads a lot. He knows that there's no project without microservices, so everything is in microservice architecture in his enterprise. So the reaction happens in a different application. Okay. It also has some non-functional requirements, like the second application might be down for a while, but it shouldn't affect the process of granting the credit card or rejecting the application. After all, the fact that email server is down shouldn't affect the process of granting a card, right? It doesn't make much sense. Another requirement would be, okay, we know that there are a lot of people out there who apply for a card, and the second application, its performance might be downgraded, overflowed. It shouldn't affect the first application, this one. And there are a lot of people out there applying for cards, really, like a lot of people out there who want money, who don't read terms of conditions and apply for a card with a deadly rate. So there's a lot of performance issues might be, and shouldn't affect this application. The third one would be taking into account the fact that Stanley has been for a while in this company. He knows stuff, he knows business experts, he knows applications. He predicts that maybe some other components might be interested in that information in the future. And he wants this information to be delivered to those applications in an easy manner. So the first thought of the team was to just make a REST call in here, like this, REST call to reporting tool, let's say. Reporting tool, and if it's granted, same REST call but different data probably, I don't know. But of course, out of the box, it wouldn't prevent the process of granting the credit card to be down when the second application is offline. Like, it would effectively affect the granting process when the second application is down. Plus, out of the box, it doesn't help Stanley and his team with a big amount of information that have to be sent to the second application. And if the performance downgrades in the second application, it would affect the performance of the first application, which is bad. And also, if there are more applications in the future interested in this information, they will have to add new REST call to, I don't know, email server or something like this, which would effectively violate the open-close principle, right? The code should be open for extension, closed for modification. Stanley shouldn't add more code to the process of granting, rejecting card, just for the sake of other component being interested in the result. It doesn't scale, it introduces a high degree of coupling between the components. It's bad. So they decided to do something different. Instead of having those synchronous REST calls, they already have some message broker in place. So they will have to send a message indicating the result of the granting or rejecting process. That's it. So the message will carry information about the fact from the past, significant fact, card granted or card application rejected. And the message that carries a significant fact from our business domain, it's called an event. So they will send events to the message broker, which in turn will deliver the messages to the consumers. That's it, simple scenario. And so Stanley recaps why they want to use messaging. So first of all, the temporal coupling is gone. Temporal coupling means the need for two applications to be alive if they want to communicate. When it comes to messaging, it's not longer the case. The second application, the consumer might be down, and the message broker will deliver when it comes up again. Plus, there is built-in throttling mechanism. The consumer can consumes information, messages, events at its own pace. That's good. Plus, there is built-in broadcast and multicast scenario, right? It's very easy to add new consumers to our message brokers, to Stanley's RabbitMQ if he chooses RabbitMQ, or Kafka topic if he chooses Kafka. By the way, he will choose RabbitMQ. And two things for free. Spatial coupling is eliminated, which means they don't need to see each other, the consumer and the producer. They just need to see the broker in the infrastructure. They don't even need to know about each other, which means logical coupling is eliminated. The producer doesn't know who the consumers are. The consumers do not know who the producer is, which is the first paradigm of messaging after all. So this is why they chose messaging. He's not like a regular developer, we already said that. So he sketches architecture diagrams going towards. He's going towards this diagram. Like he will have this RabbitMQ in place, the consumer in place. He already has most of the part from the left side. He's looking now how to implement the domain event publisher. He has the controller, the application service, the entity, the repo, the database. It's all there up and running on production. He's looking now how to implement the domain event publisher, send events to the message broker. But like we said, he's not a regular programmer, right? He will do everything in a test-driven development manner. So he will start with test, he will find some solutions, some problems, and we'll see some considerations that he will have to take into account as he goes through that journey, okay? We will help him implementing that code. All right, so he works in Scrum, of course. But last week, a weird thing happened. There was no Scrum Master in the office, so he had time to code. And he had time to code, and he started coding this domain event publisher. He doesn't know how to implement that yet, but he knows that it should adhere to some specific contract. And he named this contract domain event publisher, and it looks like this. Domain event publisher, which has one responsibility, publishes domain event. Makes sense, right? He also created domain event marker interface, which is interface that is going to be implemented by every future domain event that he is going to implement. Looks like this. Domain event, it has one type, one information about the type. By the way, this is a terrible, terrible lie. It's not him. He just pushed the code to the repo, this guy. So the domain event has the indicator about type information. Might be handy when it comes to delivering messages to specific queues in the broker or topics when it's Kafka. Might be handy to subscribing just to a specific type of the event. So that's it. And as we said, he started doing test-driven development. So probably here is the code that should be affected with that. Instead of those REST calls, he will just use the domain event publisher in here, so that he can send the domain events. And having said that, he has to start with test for apply for card service, which is already somewhere there. Let's take a look. Should be in here. Yep, it is in here. So he likes Spock, as already mentioned. To test, should emit card granted when client was born in 70s or later, or the not so happy path as well. Very easy test. Let's try to implement that. So when someone tries to apply and the client ID indicates being born in 70s, let's say 12th of December, then basically a component named event publisher should be called one time. In particular, its method name published with a parameter which matches disclosure, card granted. Very simple code, right? And Stanley likes copy pasting, so do I. It's gonna be almost the same in here, but kind of different. It's gonna be 60s and card application rejected. Of course, to make it compile, he will add the dependencies in here. The one is repo, the second one is event publisher. To make it work, he needs to add the second dependency in here, domain event publisher, and to the constructor, right? Nice. Okay, so he knows about red-green refactor loop in test-driven development, but he likes to shorten it just to red-green. He doesn't have time to refactor, so let's do so. Let's run the test for Stanley and see whether it's green or not. I think it shouldn't be green. It's not, which is good. Now, Stanley is going to implement and change those REST calls to domain event publisher, publish a new card application rejected. It takes it as a parameter client ID, I believe. Yes, it compiles. And same here, but different kind of event. It's gonna be card granted. Card granted. It takes something more. It needs information about the card, about the limit. Nice. Let's rerun the test. It's gonna be green. At least Stanley hopes so. It's green. The whole build is green. It's green. So Stanley should now go to production. Should Stanley go to production or not? Who thinks Stanley should go to production? Imagine it's not Friday evening. Imagine it's like Monday, 12 o'clock. Okay? Should Stanley go to production or not? Stanley quickly realizes that there is no implementation of this interface. He's not that incompetent, let's say. So he will start doing some more testing and figures out that probably this unit test is not enough. He needs something more. So he will start writing some integration test. Now in JUnit, because why not? He knows a lot of frameworks, apparently. So he will try to run an integration test with add Spring Boot test. It will bring up the whole Spring context, and it will catch the behavior, the problem with lack of the bin, the implementation, right? It should at least. So he will go like this. The REST controller will be called. When the REST controller is called, someone applies for a card with client ID in 70s. Let's go like this. Then, to be honest, I don't know what yet. Stanley does not either. So let's leave it like this and copy paste for the second test. Should be 60s. Something should be asserted in there, but Stanley doesn't know what yet. So he thinks about implementation part. So he will start implementing the domain publisher. And he recalled being on a conference called Spring I/O in Barcelona, and there was one guy talking about Spring Cloud Stream framework, which is basically, who is like Stanley in here and heard about Spring Cloud Stream? Couple of people. Okay, so basically, this is a framework, a tool which allows microservices to talk with each other via messaging infrastructure without having to write all of this infrastructure code that connects to Rabbit or to Kafka. Okay, so Stanley is going to use Spring Cloud Stream. We're gonna see how in a while. He chooses RabbitMQ as his broker because there is running instance running RabbitMQ always on his local machine and in his production. So that's why he chose this Rabbit. He will name the publisher to RabbitMQ event publisher, right? Makes sense. And the beauty of Spring Cloud Stream is that it comes with a abstraction of channels. So our application, Stanley's application, will talk to the channel so that he can focus on business code, and the channel will be bound to a specific destination based on magic, or so-called auto-configuration. So class path scanning. So the channel will be bound, for example, to RabbitMQ instance, RabbitMQ exchange, excuse me, when there is a RabbitMQ binder on the class path, which is the case for Stanley's code. If it was a Kafka binder, the channel will be bound to Kafka's topic. That's the beauty of Spring Cloud Stream. It's exchangeable. It's easily exchangeable. The other beauty is that it comes with the predefined set of channel definitions. So there are common scenarios like my application talks with an outbound channel, just with one outbound channel, so it's producer to one channel. In Stanley's case, it's going to be the application on the left side. That means it's a source. You can use the predefined definition from Spring Cloud Stream, which is called source. The other one would be just contrary, sync application that talks to one inbound channel, that listens and subscribes to one inbound channel. It's called sync. So having said that, Stanley can go and implement to RabbitMQ publisher using the source definition. He will inject the source from Spring Cloud Framework streaming messaging. Yes. Out constructor parameter, and now he can just with one line of code communicate with Rabbit, which is cool. Source.output.send new generic message, and the payload will be just event. Nice. As we can see, the source is just an interface which indicates the channels, one output channel named output. Cool. And this output channel will be mapped to a specific destination by class path scanning and by properties output channel destinations named channel. That means the exchange will be named channel. Simple enough, right? But Stanley forgot to mention that he wants the information about the type of the event to be present, not only in the payload, but somewhere else, like in the metadata. And if it was HTTP, he would have used HTTP headers to indicate the type of the event, for instance. But luckily enough, in messaging, he has the same possibilities, and Spring Cloud Stream allows him to do so without with 2 lines of code, to be honest, like this. Headers, magic. Headers, and pass headers like here. He passes type as a header named type, and that's it. Now the consumer will be able to deduct the type by the header of the message. Okay, so he will now go back to the test. He is doing test-driven development, right? So he now goes back to the test and sees, okay, but I don't want this code that I just have written to be present in my test code, because it's going to connect to RabbitMQ instance, which will fail integration test, because I don't want to have up and running RabbitMQ instance while I do integration testing, right? The test should run in isolation, should fail for one reason, shouldn't be dependent on some third-party applications running on my machine. It's against all of the paradigms I have read in all of those cool books. So what I'm going to do, thinks Stanley, is I'm going to replace that code that I have just written with some different bin, just in my integration test. Why not? So I know this annotation called mockbin. Who here is like Stanley and knows mockbin? Basically replace the bin from production with a mockbin for testing purposes, right? Simple enough. So we'll implement domain event publisher again, not implement but inject as a mockbin. And now he's able to do good old-fashioned Mockito style. So Mockito verified that domain event publisher was called, its method publish was called, with an instance of card granted event, right? Makes sense. We have to import that and copy paste to the second scenario, and Stanley has to change the event, card application rejected. Now Stanley can run the test. Hopefully it will be green. Who thinks it's gonna be green? No one. Of course it's gonna be green, it's a demo, right? It should be green. At least I hope so. It's green, cool. So now Stanley can go to production, right? Unit test, integration test, Friday evening, we forget about that. It's Monday morning. So Stanley should go to production, but you know, he has this bad habit he's really afraid of and ashamed of. He doesn't tell that to anyone, but he prefers to run the code locally just before pushing the code to the repo. And no one's looking because it's Friday, 6 p.m. or 6:30 p.m. So no one's looking. He will do that right now. No one's looking. So he'll just start the application to see whether it just starts or not. It's Spring Boot application. It's going to start in no time, embedded something, right? It doesn't start. So the test passes, but now it says that apply for card service misses a dependency to a domain event publisher. Why? Stanley has no idea why. Okay, he forgot to add the add component annotation in here, right? So how come did the test worked? Like, Stanley is very confused. Can someone help Stanley? How come the test worked? Like, unit test, okay, but integration test didn't work because he wasn't so careful enough with mockbin annotation, right? He should have been more careful and read the docs. It says that if no bin is present, somewhere around here, yeah, a new one will be added, which is by design. It's neither good nor bad. It's just by design, and Stanley didn't know about that. So he was really like sad about that, and he added this. He figured out what is wrong. He added this annotation, add component, but he thinks, okay, there must be a better way to test this code. There must be a better way. Then it hit him. He went on this talk about Spring Cloud Stream at Spring I/O in Barcelona, and there was some part of this talk about testing, built-in testing tools for Spring Cloud Stream. One in particular named Message Collector. And Message Collector, in its beauty, can allow to use the same code like this for production environment and for testing purposes, but underneath the framework will change the destination from real Kafka or real RabbitMQ exchange to in-memory internal java.collection.blocking queue, so that he can use it during testing. And he blames the last failure on the unit, so he will go back to Spock right now and write this test, because now he knows that he will examine the same code as the production. But before doing so, he recaps what he has done so far. The unit test examined the apply for card service in isolation, just this code, and examined whether it invokes proper methods on the main event publisher, but it doesn't check whether the main event publisher itself is properly implemented, right? It's a good test. It's so-called TDD Mockis style. It drives Stanley towards good design, minimalistic design, but it doesn't check enough things to be sure to go to production. The second test, for instance, the integration test with Mockbean, bootstraps the whole Spring context, the MVC, the entities, the JPA, even embedded database, but it still doesn't check the main event publisher. It replaces that with the mock, like the previous unit test, and it's longer. It takes longer to get the result. It bootstraps the whole context, so it gives no value. And Stanley just realized that this test is useless comparing to the previous one, and it's longer. It can be basically deleted. So now he's going to write a test with message collector, which will examine the same code as the production environment, which is cool, as the production bin, which is very cool. Just the, let's say, toggle will be changed from RabbitMQ exchange to internal blocking queue. And yeah, let's do so. Let's help him and write this code. It should be somewhere around here. Yeah, apply for card with event. It's this one. Cool. I will make it a little bit bigger. Nice. Okay, so he has to auto-wire the message collector. He has to auto-wire the source for definitions of the channels. He has to define the blocking queue in which all of the messages will be stored, right? And he will have to initialize this generic, this blocking queue and say, okay, you know what, message collector, you're gonna collect all of the messages in this blocking queue from what channel? From this one, from source output. That's it. Simple enough. And now he's going to copy-paste some stuff from the previous example, or we can write it from the scratch. It's not that hard. So when someone applies for a card via REST API again, apply for card, new card application, let's say 77 again, then basically now Stanley is able to check what's happening in the events blocking queue. It's very cool. He can do like this. Events, hey, the events, give me the last event, just calling the method poll. He can, for example, for instance, check the headers, whether the headers contains proper value. The proper value would be, in this case, card granted. In the second test, it's gonna be almost the same, 60s, and card application rejected. I hope there's no typo in here. And this test would have caught the problem with lack of add component annotation, which is cool. And the same code is being tested the same bin is being examined in production and in testing phases. Fingers crossed for Stanley it's gonna be green. It's green, it's cool. So this is the setup that Stanley is testing right now, and now he can go to production, right? It's the high time he went to production, but it's almost 7 o'clock. Really, still no one is looking, so he thinks, okay, I have in place the producer. I will run the producer. The RabbitMQ is always up and running on my machine. You know what? I will just run the consumer and send some message via HTTP and see whether they can communicate. And last sprint, as I already mentioned, Stanley got plenty of time, so he even started coding some part of the consumer side, and it looks like this. He didn't have time to implement it fully, but he started just a small scratch. Messaging consumer. It has just 2 methods to indicate 2 consumers of 2 different type of events. And depending on the event type, a specific invocation handler will be invoked. So add stream listener is an annotation from Spring Cloud Stream, and it can register some invocation handler depending on the condition, for example, from header. Okay? And by the means of course, the target, which is sync input, contrary to source output in the previous application. So he'll just run those 2 applications right now. He'll start with the second one, consumer messaging application. And the first one, messaging application. If they are up, the first one is up. The second one is up right now. He will do curl to the first application, HTTP post apply for card. This application should process the information, should raise a specific event to RabbitMQ. RabbitMQ exchange should deliver the message to the consumer, and Stanley should see something in the log statement, right? So, okay, let's do the curl. Should be somewhere in here. I believe no one can see that. Even I can see that from here. But it's you have to believe me, it's posed with a body indicating being born in 70s. So we are expecting HTTP 200 and granted, card granted. Let's do so. It is 200. I can zoom it in a little bit. No, doesn't work. Okay, anyways, you have to believe me. Same in here. 55, let's say, should be card application rejected. Let's take a look at the logs from the consumer side. It's gonna be granted the first one and rejected the second one. So it works. They can communicate. So yeah, I can zoom it in. Cool. He also prints out some client ID in here. It works, but yeah, it's null. How come it's null, says Stanley. He's really, really upset with that. Like, he doesn't know what happened. Like, unit test, integration test, test with message collector, running one application locally, running two applications locally with RabbitMQ, eventually caught the bug. Like, this amount of testing, and still I have to bring up two applications to see this kind of problem. So he starts to thinking, okay, what could have gone wrong? Like, what did I do wrong? So the headers are okay. The message comes to the broker delivers to the consumer. The good handler is being invoked according to the message type, so it works, headers works. The payload doesn't work. What happens to payload? Okay, it's being serialized, deserialized. In Spring Cloud Stream, the default serialization is JSON, so probably message converter, Jackson. I know, thinks Stanley. It's Jackson. It has to be Jackson. Like, who else, who on earth didn't have problems with Jackson? There are some lucky guys. Cool. So Stanley has problems with Jackson, but he is very experienced with Jackson, so he knows that probably some POJO that indicates the event, that represents the event, might be incorrectly created, let's say. So let's take a look at this POJO. It should be somewhere around here in the first project. Let's say card application rejected. Yeah, it doesn't have getters and setters, and by default, I guess, and Stanley guesses so as well, it will not work without some configuration and so on and so forth. So, okay, he will add getters to client ID. He will start with client ID. We make it private. Add getter, rerun the application, and see whether that was the case. By the way, he's still not satisfied, even if that's the case, because he wants to catch this behavior during testing, right? Okay, it started. Let's run the card rejected. It's gonna be this one, and take a look at the logs. And now it works, so it was Jackson. Okay, so but he's discussed, like how to do that during testing, how to check during testing that this thing can happen in production. He doesn't want to bring up 2 or 3 applications with running instance of RabbitMQ in order to catch that. It's insane, right? And then it hit him again. It was his good day, by the way. There is this framework or this tool called Spring Cloud Contract. Who is here like Stanley? You've heard about Spring Cloud Contract. Yeah, we all are Stanleys today. Cool. So Spring Cloud Contract, so far he has thought it's only for REST APIs, but there's this guy that talks a lot about contracts, and he got to know from him that it's also for messaging, actually. How does it work? It works in very simple manner. So the producer has to design the contract. Producer being the application that grants or rejects the application. It provides a contract. The contract can be in YAML or in Groovy. Let's say we'll take a look at YAML, and it looks like this. So let's hide that. Cool. The contract, say the name of the contract is card rejected. It's gonna be triggered by send rejected. That's the trigger message, the code that Stanley will have to implement to check this contract during build phases. And when this code is invoked, send rejected, Stanley expects some message at the output. message should be arriving to channel named channel. Makes sense, right? And the message should have those headers, this body, and this matches those matchers. Simple enough. A simple construct. It can, of course, get more complicated and more complex. The beauty of this framework is that automatically from this test, from this contract, a JUnit test will be generated. And it's going to be stored in generated test sources, like here, you see, target generated test sources, infrastructure test. It's generated automatically out of this contract. When send rejected is being invoked, then on channel named channel, the response should not be null, should have type, should have content type, basically all the things that he has specified in the contract. The part that is left is implementation of send rejected. Basically, the best way is just to invoke the publisher, auto-wired publisher. Yeah, it should be now when the RabbitMQ is present. The event publisher, it can be like this. And the test should code this problem with wrong serialization. Let's run it and check. We added the getter, but we didn't add the getter to timestamp, basically. So it should fail on timestamp, I guess. And it's failing on timestamp. So the test catches this behavior, which is cool. Let's add the getter from timestamp, and let Stanley rerun this code, this test. Create getter, nice. Rerun the test. Did Stanley add the getter? Yeah. Should be green right now. Yeah, it's green. So Spring Cloud contract allows him to do testing with serialization. And someone may ask, okay, but let's say junior developer approaches Stanley and asks, okay, but you could have checked that during your testing with message collector, like here. Why didn't you check payload instead of headers in here? It's a firm question, right? The problem is that in previous version of Spring Cloud Stream, it didn't go via serialization phase with message collector. It just went to directly the same object that was thrown to the main event publisher would have been sent in here, saved in here, which means it would have been with proper content, because the serialization doesn't happen, don't happen, which happens with Spring Cloud contract, which is cool. Plus, he now can import the contracts verified by the producer by this test as an artifact like jar and import at the consumer side and have so-called end-to-end test or something like this, close to end-to-end test, without having the message broker in place, which is very cool. So now, finally, Stanley can go to production. He has the test that examines the right part of the application, the consumer, the left part, the producer, and RabbitMQ tested locally. So he went to production. It was really fine. The code was there for 2 weeks or so, and then senior enterprise architect came from vacation, and he's pointing fingers at poor Stanley. Like, how come you passed the recruitment process in our company? How come your code passed the review process? Like, what did you do there? Stanley was a little bit confused. Like, man, unit test, integration test, message collector test, Spring Cloud contract, Spring Cloud Stream, running locally, both applications, RabbitMQ local. What could I have done more? And he was like, I don't know, but take a look at your code. In the first place, the first line of code that you pushed to the repo is like this. Apply for card service. Your method, apply, which is an auto to add transactional, goes to credit card repo.saves and then publishes the event to the main event publisher, which in turn go to RabbitMQ and goes back. What if RabbitMQ is down? Asked the architect. Stanley was like, then the transaction will be rolled back, everything is fine, what do you want? What if RabbitMQ is not down? It acknowledges your message, but your code goes out of this method body, Spring Proxy takes over and tries to commit to the database, and your database is down, or your application is down. Stanley was a little bit confused. Like, okay, so that means I'm sending an event to a message broker indicating card was granted, and yet the card was not stored in my database. That's bad. Stanley was really, really sad about that. He spent a lot of time developing that software. So he took some time off to work remotely because he was really afraid of facing architect in the kitchen. So he started working remotely. And after 2 weeks, he came back very happy because he found a solution. The solution was like this. Hey, dear architect, I have a solution for you. I have just a different implementation of the main event publisher, which looks like this. Hey, take a look. It's really simple. He was really happy. I go to implementations. The second one, I basically, on method publish, I save the event to the same database as the credit card is stored. That way, I have ACID guarantees, atomic transaction, either both will be stored or nothing will be stored. That's cool, right? And then I have this publish externally method, which goes every 2 seconds and looks for events that were not already sent, send them in an old-fashioned way to the evident queue, marks as sent, and it goes out of the method. By the way, it's also transactional. And senior architect was burning from the inside. Like, he couldn't reply how he wanted because he was after some nice talk with HR department after his previous behavior towards Stanley. So he also took some time off, and he decided to write an email. Dear Stanley, I appreciate your effort, but I have to raise your awareness about what you have done and how you effectively move the same problem from your apply for card service to your new shiny domain event publisher, which basically does the same. There is add transactional, and you try to save to the database, like here, and connect to the message broker. The same thing can happen. Stanley was really excited that senior architect replied that way because he had predicted that. He even had prepared a draft as a response for this response and waited 5 minutes to click send because he was like very happy. He expected this kind of response, and he was saying, dear senior enterprise architect, here is Stanley. I appreciate your effort for taking a look at my code, and you are right. But in this case, I'm going only to send an event card granted if card is going to be stored in my database. That's correct. I cannot deny that. The problem that you are talking about is as follows. I can send the event to the message broker, and then I'm not going to mark it as sent because when I try to commit or Spring tries to commit, the message, the database can be down, which means my scheduler will pick it up in the subsequent invocation, which in turn will be delivered more than once, or twice, or 3 times, or 4 times, or 100 times. When I have like an idempotent consumer which can deduct that, okay, I have seen this message, then it's okay. By the way, this is called at least once delivery. You should have known about that, dear architect. And there was also a different option that I could choose. The different option is to fire a callback just after successful commit to the database with the credit card. Then, fire and forget. I'm sure that credit card was stored. I'm firing the callback by a means, for example, of transaction synchronization manager. And if it's okay, then okay. If not, I have at most once delivery, dear architect. Which one is better depends on our business context. Let's imagine that this message carries some information for marketing purposes. I would guess that at most once would be enough. But on the other hand, it can have some information about how to activate the card. In this case, delivering this message more than once is gonna cause less problems than delivering that 0 times. Can you agree? Yours, Stanley. Senior was like, senior architect developer and architect, enterprise architect. Those titles are really, really hard. He was really, really pissed off because Stanley was right. And you must know that senior architect is not the kind of person who would leave the conversation without the last word. So he started thinking, like, what can I respond? Like, what can I respond to this message? Because he is right. This guy is right. He was thinking. Stanley tries to store something in a database, send an event to someone. So he is trying to synchronize 2 different data sources. That's why the problem, hence the problem. He thinks, maybe I can get rid of one of them. And which one? Maybe I can deduct the other one from the first one. If yes, then which one from which one? And he thinks, okay, the state is being mutated all the time. If card is granted, revoked, and so on and so forth, it's being like replaced in the database, which means I cannot deduct the changes, the domain events that led to a specific state. But from the events, I'm going to get the state. And he's going to write an email to Stanley saying, hey, you could have just stored events and then used event sourcing to rebuild state. This is called event sourcing, dear Stanley. You should have at least proposed that solution. I'm not saying it's a silver bullet for our situation, but if you had chosen that, you would have had only to write to your event store, which basically RabbitMQ is not good for. But I'm really worried that you didn't mention that. Always yours, Senior Enterprise Architect. Stanley was like, okay. He didn't reply anything back. From my side, I can tell you that there are some advantages of different advantages of having this event sourcing scenario in place, or in having just events stored somewhere, because some components, different components, might have a different perspective of the event log. Like, let's say we don't necessarily have to build state of credit card out of these events, but also some different component may take a look and say, okay, there are some card withdrawn event next to each other, two of them, very close to each other. One is in Denver, the other one is in Barcelona, and I can build like easily fraud detection mechanisms and different kind of stuff by having a different perspective on the event log. And this is how real life works anyways. So I used to have this girlfriend, and let's say that our event log of our relationship was really intense. And she used to come back to the events from different things, and we used to argue about that. I was like, honey, this is okay, because you have an optimized projection for your needs, and I have optimized projection for my needs. This is how event sourcing works. And it was okay until she started versioning the event, so adding the content to the event. It wasn't even backward compatible. So I said to her, it got to stop, like it got to stop. We have various perspectives, it got to stop. Let's watch some talk about event sourcing on YouTube, there are plenty of them. And it got to stop, and it stopped, really. We broke up. And so event sourcing allows us to take a different perspective on some event log. So Stanley went to production with his different, at least once, delivery mechanism. Senior Enterprise Architect was really happy. The conversation ended up peacefully. They didn't have any more questions. They connected to Twitter, YouTube, and LinkedIn, Google+, to Spring channels, by the way. And he didn't have any more questions, but maybe you have some questions. I don't know if we have time. We have 2 minutes, so I'm here around. You can find me also on Twitter. Here's the link to the code. It's up and running on Spring Cloud Samples, GitHub. Here's my Twitter account. So I would like to thank you for coming. I wish you a nice evening in Barcelona, which is great, and safe travels if anyone is coming back to their country tonight. Thank you.